Alright, so my project, I did a welcome home bot. Now on the front here we have our camera module, which I'll show in a second. But basically for this, I chose to use the Raspberry Pi 4, and this one has 8 gigabytes of RAM here. I chose 8 gigabytes of RAM, one, because that's what came with the model I got off of Facebook Marketplace, which was awesome, but two, it supports the image processing that we need for the use case. We have our SD storage on the side here. You can see the SD card is slotted in there, 32 gigabytes, and that's going to store our user profiles. That includes the picture that the image processing is going to check against to identify the person in the camera, as well as any other relevant data like their name. Over here, we have the Wi-Fi and the Bluetooth chip. It's on board, so that was very useful. We have our CSI port here. That's the camera serial interface. That's what connects my camera module on the front here to the motherboard itself. We have our two micro HDMI slots. I'm going to use these when we actually run it. I'm going to connect it to a capture card and put it into my computer so that we can actually get a preview of it running alongside the client's interface. And then you have your power supply here. And again, so on this side, we have the camera module. I'll unscrew that, and then it also came with a higher lens because the person that I purchased this from was using it for time lapse. So I will be using those in conjunction in a second. And then as far as the software goes, I include a 64-bit operating system, so Raspberry Pi operating system, because it was the most convenient. It automatically worked with the camera module. The camera module is a Raspberry Pi camera module, so there were some issues when getting it to work, but it was pretty much plug and play. Back end, I use Google Cloud Firebase. They have a messaging service that we're going to use, communicating from our Wi-Fi adapter to Google Cloud, and then from there it'll deliver messages to the client side that somebody is at the camera or at the door. Depending on the use case. That handles the authentication. As far as the image processing, everything was done in Python, so we used OpenCV and face recognition libraries for the facial encoding and matching, as well as the camera functionality. And then the front end is all in JavaScript. And so that pretty much covers the stack, the software that we used. I'll set this up here in a second, and then we'll jump into an actual preview. So here's how we have it set up. We have the power adapter in. You can see it's powered on, and this is how it's going to be for our preview, other than the micro HDMI cable. I'll connect here in a second. But next, let's move on to seeing the client side and actually seeing the functionality of the message delivering and the facial recognition and all that. So here we have an actual demo. We'll see me start the notifications, and I'll move my face into the frame, and this shows kind of when the system recognizes a known person coming into the screen. Again, the front end was all done in JavaScript, and then I have my brother step in, and that shows when there's an unknown person recognized. So we see the notifications deliver kind of differently depending on the person. We don't spam if it's the same person that goes into the frame, so we'll see that when I move back in the frame at the end, it didn't send another welcome back. And then let me share some of the key things I learned from this project. So I would say the most important thing was to plan for the components to not communicate effectively. Luckily for me, I really just had the Raspberry Pi and the camera module itself. And because the camera module was a Raspberry Pi module, it was very compatible as long as I had the correct drivers and everything. However, I still ran into issues with the module not consistently being recognized by the system. So I really thought about the importance of creating some kind of robust error handling. And what I did was create scripts that would automatically reinitialize the camera if it failed, rather than trying to assume that the hardware would always work. Especially because in testing, I would manually have to actually close the program and restart it. So this was a lot better in the long run, creating something robust that, I could actually run on the Raspberry Pi and have it be more reliable and count on it to work effectively. I also ran into some networking issues, particularly while trying to maintain a stable Wi-Fi connection. I found that sometimes the messages were not reaching the client side consistently, and so I had to implement some kind of messaging queue within the program itself. And so if the connection had dropped and we were waiting for it to be restored, then the queue would recognize when the connection was restored and deliver whatever notifications were waiting on the system. And then some other lessons were, error handling, ensuring that we were logging things for debugging. That's very standard, and I think that's across a lot of projects. And then the value of the community resources. Like, everybody has already made so many different projects with Raspberry Pi, so the Raspberry Pi community, and going on to, Stack Overflow, or just Googling whatever I needed, those solutions were very invaluable in helping me create, bring the idea of what I was trying to do to life.